This is SpaceTime Series 24, Episode 120, for broadcast on the 22nd of October 2021. Coming up on SpaceTime, signs of water in the red planet's Jezero Crater, the large effect of solar activity on Earth's energy budget, and the European Space Agency's CHEOPS space telescope now well over halfway through its planned mission to study distant worlds orbiting other stars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Ever since Perseverance landed in the red planet's Jezero Crater back in February, the rover and its team of scientists back on Earth have been working hard at exploring the crater's floor, which once held an ancient lake. The car-sized six-wheel rover's primary mission is searching for signs of ancient microbial life on Mars. As part of this process, it's collecting a cache of samples for eventual return to Earth. Most recently, Perseverance's onboard instruments have been analysing what are thought to be igneous rocks on the crater floor, which were deposited there by a volcanic lava flow. Deputy Project Scientist Katie Stack Morgan from NASA's Jet Propulsion Laboratory in Pasadena, California, says the idea that these could be volcanic rocks is appealing from a sample return perspective, because igneous rocks are great for getting accurate age dating. Jezero is one of the few ancient crater lake sites on Mars that seems to have both incredible sedimentary deposits as well as volcanic deposits, which could help construct a geologic timescale of the red planet. The lake system and the rivers that drained into Jezero Crater were likely active around 3.8 to 3.6 billion years ago. But the ability to eventually directly date the rocks in laboratories on Earth will provide the first definitive insight into the window of time that Mars may have been a habitable planet. The Mars we see today is a freeze-dried desert. But there's ample evidence that at some time in its past, billions of years ago, the red planet was a warm, wet world with a thick atmosphere and habitable conditions which could have supported life. Using Perseverance's abrasion tool, which scratches the top surface of the rock to reveal the material underneath and its textures, mission managers discovered that the crater floor seems to be composed of coarser-grained igneous minerals containing a variety of salts. Observations suggest that water caused extensive weathering and alteration of the crater floor, meaning that the rocks were subjected to water for a significant period of time. After using its onboard tools to analyze the characteristics of the crater floor, Perseverance collected a rock sample using its drill. However, after Perseverance completed its first attempt, the core sample tube came up empty. Scientists think the core sample must have been pulverized during the drilling. Stack Morgan says the rock literally became so altered and weakened by interactions with water that the vibrations and strength from the drill pulverized the sample. Scientists then targeted another rock which appeared to be more resistant to weathering, and Perseverance was able to successfully collect two core samples. Perseverance's cache sample will ultimately be part of a multi-spacecraft handoff, still in development right now, which will hopefully be returned to Earth sometime in the 2030s. It's going to require a number of spacecraft, which NASA and the European Space Agency are now working on. One will fly to Mars orbit. A second will then descend down to the Martian surface, where it will deploy a rover that will collect Perseverance's sample cache, return it to a third spacecraft mounted on the lander, which will launch back into space to rendezvous with the orbiter, which will then return the sample to Earth, where a fourth spacecraft, a re-entry vehicle, will parachute the sample back down to the ground. It'll be a complicated mission, and there's a lot still to work out. Once back on Earth, scientists in laboratories will date and analyze the rocks to see if they contain any signs of ancient Martian life. The rocks on the crater floor weren't originally envisaged as being the prime astrobiology target of the mission. But as always, Mars is simply full of surprises, with scientists finding that even these rocks have experienced sustained interaction with water, meaning they too could have been habitable for any ancient Martian microbes which may have existed in the past. This is SpaceTime. Still to come, the large effect of solar activity on Earth's energy budget, And the European Space Agency's CHEOPS space telescope, now well over halfway through its planned mission to study distant worlds orbiting other stars. All that and more still to come on SpaceTime. A new study has confirmed that the Sun and galaxy have a major impact on Earth's cloud cover and ultimately on the planet's energy budget. The findings, published in the journal Scientific Reports, are based on measurements of cosmic rays which filter down through the atmosphere. The study's authors from the Hebrew University in Jerusalem and the University of Denmark trace the consequences of eruptions on the Sun, such as coronal mass ejections and sun flares, on clouds in Earth's atmosphere and ultimately on Earth's energy budget. They tested the cosmic ray effects in the atmosphere for about 2 weeks. They found that when solar explosions occurred, it reduced the cosmic ray flux coming from deep space which reaches the Earth, and that temporarily reduced the production of small aerosols in the planet's atmosphere. Aerosols are clumps of molecules in the air which can grow to seed water droplets which will eventually form low-level clouds. So, the drop in aerosols in turn reduces the cloud cover, which affects the climate. Less cloud cover means more of the Sun's heat reaches the Earth's surface. The findings use detailed satellite observations from the Ceres instrument on NASA's Terra and Aqua satellites. The data shows that the drop in cloud cover meant that the Earth's surface was absorbing almost 2 watts per square metre of extra energy within 4 to 6 days of cosmic ray minimum. The research shows how cosmic rays help make aerosols and accelerate their growth to cloud condensation nuclei. The findings support previous research by the same team, which predicted that the effect should be most noticeable in low-altitude clouds over the oceans. The authors point out that solar effects in this study are too short-lived to have a lasting effect on the climate. However, they do demonstrate the likely effect of solar activity and cosmic rays on climate over longer timescales. This is SpaceTime. Still to come, the European Space Agency's CHEOPS space telescope now halfway through its mission, and later in the science report, a successful test of America's new hypersonic missile. All that and more still to come on SpaceTime. The European Space Agency's CHEOPS space telescope is now over halfway through its planned mission to study distant worlds orbiting other stars. CHEOPS stands for Characterizing Exoplanet Satellite. It was launched in December 2019 aboard a Russian Soyuz frigate rocket from the European Space Agency's Kourou spaceport in French Guiana, together with 3 small CubeSats. CHEOPS was deployed into a 712-kilometre high sun-synchronous orbit. The 273-kilogram spacecraft uses a 30-centimetre telescope to determine the size of known exoplanetary bodies. It specifically targets stars hosting Earth to Neptune-sized planets. The data gathered by the mission allows astronomers to estimate the mass, density, composition, and even likely formation history of these exoplanets. ESA TV's Dominique Detain is speaking with CHEOPS project scientist Kate Isaac.
CHEOPS is the satellite that will be looking at exoplanet, and next to me is Kate Isaac. She's the project scientist of this mission. So explain to us what it is for.
With pleasure. CHEOPS is a satellite in ESA's science program. The acronym CHEOPS stands for Characterizing Exoplanets Satellite, and that is exactly what we do. We observe stars that are known to host exoplanets. So in that way, we know where to point and when to point. And we will measure the output of these stars and look for the transit of the planet across the disk of the star. So we will look for the small changes in light that will take place when a planet moves across the star. Our observations could take 6, 8, 10, 12 hours. And by measuring the dip, we can determine the size of the planet. By combining the size of the planet with its mass, we're able to determine its mean density. By combining this with information that we have about the host star itself, we can start to say something very concrete about the composition of the planet, its internal structure, and so start to lead on to its structure, formation, and evolution history. Very important information about planets beyond our own solar system.
And this is the first time this is done. I mean, you know where to look at, but you don't know exactly. I mean, this is the added value of CHEOPS.
The added value of CHEOPS is we're following up on known targets. So instead of missions such as Kepler, TESS, and indeed Plato, ESA's future exoplanet mission, we know where to point. So we're able to make very efficient observations. We move and point towards a star when we know that the planet is going to transit. So instead of spending several months, maybe, pointing at a blank fraction of the sky, looking for the transit, monitoring very many thousands of stars and looking for small dips in their output, we're able to go quickly around the sky, maybe spend 10, 20, 30 hours on known stars, known bright stars, and to measure the sizes of their planets in that way.
You mentioned the dip, meaning that it will be something in front of the star or the sun, because it's solar systems you are looking at in a way.
Planetary systems. So what we're doing is we're looking at the planets as they orbit around their host star. So in the same way that the Earth goes around our star, our sun, other planets orbit their own host stars. And what we will do is we will monitor these stars and we will look for these dips. As the planet moves across the disk of the star, as seen by us from a large distance, we're able to determine the size of the planet from the small dip in the output of the star, so in the light that we measure from the star.
You will be able to tell us if there are Earth-like planets and life on this?
We'll be focusing on small planets, so Earth to Neptune size planets. And by combining the sizes, the very precise and accurate sizes that we will get with measurements from CHEOPS, with measurements of mass that will be made from telescopes and observatories on Earth, we can get the density. Now, as you know, density is something that tells us about what the planet is made of. Something that has a high density, something like iron, is very much more compact. Whereas if something has a low density, it's more gassy. Earth is somewhere in between. And so by being able to work something out about the density, we're able to say something about whether the planet is Earth-like or whether it's more gassy instead.
That's CHEOPS project scientist Kate Isaac, who was speaking with ESA TV's Dominic Detain. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that some classic antidepressants could help improve modern cancer treatments. The findings, reported in the journal Science Transitional Medicine, showed that they slowed the growth of pancreatic and colon cancers. And when combined with immunotherapy, they even stopped the cancer growth long term, with tumours disappearing completely in some cases. It happens because in depressed people, the concentration of the neurotransmitter serotonin is reduced in the brain. But serotonin also influences many other functions throughout the body. In fact, the majority of the hormone isn't located in the brain, but stored in blood platelets. And serotonin has already been linked to carcinogenesis. Serotonin reuptake inhibitors, which are used to treat depression, increase serotonin levels in the brain, but they also decrease peripheral serotonin in the platelets. And it's that reduction which is thought to improve cancer treatment. The United States Air Force has undertaken a successful free flight test of its Hawk or hypersonic air-breathing weapon concept. The Raytheon-built missile is powered by a Northrop Grumman scramjet. A scramjet is a supersonic combustion ramjet. It was drop-launched at high altitude from an aircraft and then initially accelerated with a rocket engine before the scramjet took over. DARPA mission managers say the free flight test successfully demonstrated the Hawk vehicle integration and release sequence. It safely separated from the launch aircraft. Its booster ignition and boost phase operated normally, booster separation then occurred as it should, and the scramjet engine ignited just as it should, providing a hypersonic cruise. The flight showed the scramjet compressed incoming air mixed with its hydrocarbon fuel and began igniting that fast-moving airflow mixture, propelling the cruiser to a speed of well over 5 times the speed of sound while remaining within the atmosphere. Hypersonic missiles travel so fast, anti-missile systems can't stop them. And they hit their targets at such high speeds, they impact with a kinetic energy equivalent of 4 tons of TNT. So they don't need to carry any explosives. Once operational, it's envisaged the Hawks will be mounted on FA-18 Super Hornets and Growler fighters, as well as F-35 stealth fighters and P-8A Poseidon maritime patrol aircraft. Archaeologists have discovered a previously hidden neighborhood linked to the ancient Mayan city of Tikal in Guatemala. The area, which was covered in thick rainforest, was detected by LiDAR analysis. It revealed that what was previously assumed to have been natural hills was actually an 1800-year-old ruined citadel. The findings, reported in the journal Antiquity, showed that this neighborhood was apparently designed to look like the ancient Mayan city of Teotihuacan, the largest and most powerful city in ancient Mesoamerica. Scientists say the newly discovered structures provide game-changing evidence that the imperial power of Teotihuacan exerted considerable influence on Tikal. A new paranormal helpline in India is providing the general public with a scientific alternative to the usual clairvoyants, exorcists, soothsayers and ghost hunters. Tim Mendham from Australian Skeptics says the Paranormal Helpline helps dispel people's blind faith and superstitions by giving them scientific explanations and logical reasoning to the reality behind the apparent paranormal events people think they witnessed.
When I first saw this story, I thought, here's someone who can sort of advise you on, who's who of ghosts, etc., and someone who's going to support your paranormal belief. It turns out to be a particular skeptic. He's a paranormal investigator, but he tends to go in to find out the truth behind ghost claims, not the supposed truth, but look into and be a skeptical investigator. So he's actually set up a helpline for people who are concerned about ghosts and hauntings, etc., in India, which is a fairly strong stream of superstitious beliefs in India, and he's there to help them out and probably explain what's really happening in their situation. So it's a skeptics helpline, which is frankly a very interesting thing. I certainly get phone calls from people, being on the front line of the skeptics in Australia. I get phone calls from people, some of whom are very distressed, and I try and give a bit of explanation for what might be happening to them, but obviously I'm not medically trained. I'm not trained in psychology or anything like that, so I can only go so far. But it looks like this guy has had a lot of experience in paranormal investigation on his own right, visiting the haunted houses and that sort of stuff. So he's had some runs on the board in knowing what exactly is going on. But he's had about 1,000 calls coming in all the time. 1,000 calls per year. 1,000 calls per year is quite a lot of people coming forward to him and wanting explanations of what they've seen. Some people are just curious about it, want to discuss the concept. Others are really saying, my house is haunted, what should I do? So he sits down with them and says, well, what's the circumstances? Uses some critical thinking, which is always good, to say, well, let's, stop being scared, get down to brass tacks. What's actually happening, and let's see if there's another explanation for it. And that's what he does. Very useful service, because obviously he had a big market, judging by the reaction he's got.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.